All right, now that we actually have our structure over here, we're going to start hanging bacteria on there, sort of like a putrid ornament on a funky Christmas tree. All right, now the first three types of bacteria ought to be fairly familiar to us because Lord knows we see them all the time. Yep, there they are. We got a Staphylococcus, we got Streptococcus, and we got Enterococcus. So this group over here obviously is going to like oxygen or tolerate oxygen. It's going to be gram positive, and they're going to look like little berries, so they're a cocci. So if you follow this taxonomy, you'll notice some patterns begin to emerge that'll sort of make sense with your clinical experience. So if a bug enjoys or tolerates oxygen, and it's gram positive, and it's a cocci that looks like a berry, it's going to look like one of these. So it's going to be either staph or strep or enterococcus. Sort of intuitively, you should sort of think that all of those go together because, at least until recently, they all tended to be treated with the same types of antibiotics. Now, as we move along here, we're going to sort of cull some of these things. And the reason is we can come back to them later, but again, the idea is to start with some sort of reasonable, simple structure and then sort of layer additional layers of complexity on top of it. So we have the ones that we're sort of familiar with, right? As far as Listeria and Nocardia, essentially, they tolerate oxygen, they're gram positive, and their odds for right now, we don't care. Let's move along here. They're gram negative, right? They're cocci. Neisseria, it's gonorrhea. Yeah, we sort of familiar with that. But for this discussion, big old no. If they tolerate oxygen or enjoy oxygen, they're gram negative in their rods, well, then these things sort of look sort of interesting, right? Because those are Enterobacter, and which basically means bacteria that are inside the intestines, primarily the colon. And these should look real familiar to us. We have E. coli, we have Klebsiella, we have Salmonella and Shigella. Neither Salmonella and Shigella should be there. So primarily we're going to discuss these two. Actually, the break-even point, or the break point over here has to do whether or not they ferment lactose or not. Let's continue to move down over here. Streptococci, who really cares, right? Clostridium, we all see that. Clostridium difficile. Actomyces, don't care about that. Veillonella, don't even care about it, can probably not pronounce it. Fusiform bacteria, forget it. Bacteroides. So here's something you should notice as we start to look at patterns over here. For these, oxygen is poisonous. Given the fact that we live in an environment that is 20% oxygen, given the fact that almost all the cells in our body are aerobic, meaning that almost all of our systems are designed to bring oxygen to the cells. And given the fact that Clostridium and Bacteroides are both will die in the presence of oxygen, it should tell you something. These are sort of scary bugs, right? And for them to grow, there's going to have to be little micro sort of environments where there's no oxygen. Something else you should keep in mind in regards to how easy, or excuse me, how deadly oxygen is to them, is this is actually Clostridium difficile, which we all know, C. diff. Difficile meaning that it's difficult to culture, because when you pull this bug out, you've got to keep it in an anaerobic environment in order to culture it, which if you think about it is pretty difficult given that 20% of the environment that surrounds us is oxygen. Bacteroides is Bacteroides fragilis. Again, it's fragile. It's very difficult to culture because 20% of the environment around us is oxygen. Now, just as an aside, one thing you should know about these two, let's do this. The Clostridium, it should be nice if I got this a little darker over here. Right, the Clostridium and the Bacteroides. These are bacteria that are found in an anaerobic environment, and they are extremely important in abscesses. We'll come back to that, right? And so one of the reasons why you want to incise and drain an abscess is that by getting that pus out of there, you're bringing the blood back into it, you're getting rid of that large sphere of an anaerobic environment, and by bringing oxygen to these little suckers over here and here, in addition to the antibiotics, you're killing them. All right, so by putting it in this taxonomy where we're deciding, we're first breaking it down into whether or not the bacteria are poisoned by oxygen or whether or not they enjoy or tolerate it, we have a pattern that makes things a whole bunch easier when we're trying to get our head wrapped around it, right? If you think about this, there's really only sort of three groups we're interested in right now. Right? The first is going to be O2, which is going to be gram-positive cocci, which look familiar with us, and that's our first group. We really don't care about that. Excuse me. The second group will be gram-negative, right? Aerobic. So gram-negative rods, right? Which is going to be Enterobacter, which is going to be this group. So our second group, and then our third group that we care about is going to be anaerobic, right? So oxygen is going to poison it, right? And it's going to be Clostridium, and it's going to be Bacteroides, Clostridium difficile and Bacteroides fragilis, right? So break this down.